Now this is the second case of partial fraction. So in the second case we will apply the partial fraction as I told in the previous lecture in proper fraction. We can apply a partial fraction is only applicable on proper fraction. So if the denominator is consist of linear, the second case, if the denominator is consist of linear repeated factor. If the denominator is consist of linear repeated factor, then what will be the scenario in this case of partial fraction? For example, p of x divided by q of x, and the q of x is repeated. For example, p of x divided by x minus 1 whole square into x plus 1. In this case, in the x minus 1, it is equal to x minus 1 into x minus 1. So x minus 1 is repeated in the denominator. So in this case, the scenario of partial fraction is separate from the first case. So how we can apply the partial fraction tool if the denominator consists of linear repeated factor? So for example, let's take an example which is equal to, let x plus 1 divided by x minus 1 whole square into x plus 1. This is a simple example with linear repeated factor in the denominator, and this is also a proper fraction. So how we can apply the partial fraction on this function? So if the denominator is linear repeated factor, then it will be in the partial fraction form a divided by x minus 1 plus b divided by x minus 1 whole square, this point to be noted, plus c divided by x plus 1. And this way we will split the function if the denominator is consist of linear repeated factor. F, for example, if p of x minus a whole square into x minus b whole square, it will be a divided by x minus a plus b divided by x minus a whole square plus c divided by x minus b plus d divided by x minus b whole square. This case will be in this form. So here, if it is x plus 1 whole square, then it will be c divided by x plus 1 plus d divided by x plus 1 whole square. This is the second case of partial fraction. So multiply in the, this is the first step. And the second step, multiply x minus 1 whole square into x plus 1 to both sides of this equation. This is denominator, so it is equal to x plus 1 a into x minus 1 into x plus 1 plus b into x plus 1 plus c into x minus 1 whole square, multiplying denominator on both sides of this equation. So in this is the second step. Now the third step, this is equation A. Now the third step, let's split this function. Let's simplify these expressions, this term. So it is x square minus 1 plus b into x plus 1 plus c into x square plus 1 minus 2x. A minus b whole square is equal to a square plus b square minus 2ab. So it is equal to x plus 1, it is ax square minus a plus bx plus b plus cx square plus c minus c2x. So x plus 1 is equal to ax square is here, x square term is here. So a plus c into x square, the x term is here and the x term is here. So plus x into b minus 2c, and the constant is plus c minus a. This is equation 2. Now in the first equation put x is equal to 1. So if x is equal to 1 in this equation, so 1 plus 1 is 2, a into 0 plus b into 1 plus 1, which is 2, plus c into 0, so b is equal to 1. Understood? Now put x is equal to minus 1 in equation 1. So minus 1 plus 1 is 0. So a into 0 plus b into 0 plus c into minus 2 whole square, which is c into 4 is equal to 0. So this implies that c is equal to 0. Now c equal to 0. Now comparing coefficient and equation 2, so x will be equal to b minus 2c is equal to 1. So c is equal to 0, so b is equal to 1. So b is equal to 1, which is also found in the above question. So c minus a is equal to 0. C minus a, by comparing the coefficient in equation 2, c minus a is equal to 0, so c equal to 0, so a is equal to 0.